we are today organizing 7th Engineering Science Conference series, the 7th one today. Our invited speaker is from Arizona State University, Professor Dr. Kasım Selçuk CANDAN. So he will be explaining us robust smart data services for sense making in human-centered dynamic systems. And before giving him time, let me introduce Professor CANDAN first of all. And it would be a bit long, but let me tell you about Professor CANDAN. He's a professor at computer science and engineering at Arizona State University, and he's a director of Center for Assured and Scalable Data Engineering, and he's also graduated from Bilim University, Turkey, and he completed his PhD degree in Maryland University, and his primary research interest is in the area of management and analysis of non-traditional, heterogeneous, and improvised data. And he published almost more than 200 journal and conference articles, books, book chapters, and so on. He has also 9 patents. And Professor CANDAN also served as an associate editor of many journals, such as very large database journal, IEEE Transactional Multimedia. And he is currently in the editorial board of ACM Transactional Database Systems, and also IEEE Transactional Knowledge and Data Engineering, and also IEEE Transactional Cloud Computing, and Journal of Multimedia. He has also chaired many conferences, IEEE and ACM conferences, and as a chair, as a co-chair, and so on. And he successfully served PI or co-PI of numerous grants, including National Science Foundation, Air Force Office of Research, Army Research Office, Mellon Foundation, and so on. He has been also academic visiting researcher over 10 years at NEC laboratories, and also he is the member of now executive committee of ACM Sigmod, and also Professor CANDAN, also ACM distinguished scientist. He has also many awards, and also he has got more than 22,000 citations. And I have just checked his hash index is over 40. And we are really proud of you, Professor CANDAN, and it is really, I'm sure I missed many of your features, but let me briefly introduce to you. And if I missed any important, please complete those important duties. Okay, thank you, Professor CANDAN. This is our university's 95th establishment years. So this is special year of Gazi University. And in this year, we organized this science series talks. So thank you very much for your contribution and accepting our invitation to be a keynote speaker. Thank you, Professor CANDAN. Now it's your turn. Okay, thank you.
Professor Sarıoğlu, thanks a lot for this very kind and very generous introduction. I am very proud to be here. Before I start my presentation, I would like to, let me see if I can make this work. I would like to thank Gazi University. I would like to actually say happy birthday to Gazi University. I would also like to thank the organizers of the Mühendislik Bilim Conference. I understand this is a very special year, and I'm very honored to be invited to give a talk in this special edition of the event. And of course, I would like to thank Professor Sarıoğlu for the very kind introduction once again. So the title of the talk is Smart Data Services for Sense Making in Human-Centered Dynamic Systems. It's a long title. It has lots of sort of keywords here. So what I will try to do today is I will try to basically explain what I mean by a smart data service, what I mean by a human-centered dynamic system, what I mean by sense making. So since I didn't know the audience very well, I hedged my my bet. So the first half of the presentation is going to be high level. I will mostly talk about basic motivational issues and some of the underlying challenges in using data to support sense making or decision making in dynamic systems. And in the, if time allows, in the second half of the presentation, I'm going to get into some of the technical details. And we'll basically see how everything goes. My goal is not to, I have 60 slides, but my goal is not to go over all of them. I'm hoping that basically this will be a nice interaction. And one of the things that basically Zoom allows is if you have any questions, please raise your hands. I think there is probably a way to raise your hands. And if basically anything is not clear, or if you'd like to have any clarification, we can use this essentially as a sort of a two-way presentation. I think that would be, since we have the opportunity, we might leverage that. The presentation today is going to be sort of a, I'm going to say hodgepodge. I'm saying it in the positive sense of challenges and ideas that we gained over the last 5 or so years over several projects that we are running through federally funded research. And I will also acknowledge them as basically they are going to be presented. So let me go ahead and start. So what's a dynamic system? I'm not going to make a sort of formal definition of a dynamic system, but I think basically it's like art, right? So when we recognize, we see it, right? So today, all of us, right? So we are living in communities that are essentially dynamic systems. They are basically, they are complex. And they are sort of made up of basically natural and man-made processes, right? So for example, if you talk about life sciences, if you talk about energy, if you talk about security, if you talk about healthcare, if you talk about governance, all of these have multiple components. Some of those components are man-made. Some of those components are natural, and understanding and making decisions in these sort of systems and subsystems require us to have some kind of situational awareness of the dynamic system. And I will basically argue in this talk that data is key in this context. So again, so data is a key enabler, right? So today we talk about smart cities, smart decision making. This involves many things. This involves smart people, smart living, smart mobility, smart economy, smart governance, smart environment, and enabling each one of these, any of these, essentially require data. So the question that I try to answer in my research in general is, can we leverage big data technologies? These technologies include tools and services to enable communities where inhabitants live and work collectively in harmony. So there is a collectiveness. So basically we have multiple people, multiple agents, multiple decision makers, multiple consumers in the same environment, right? And this community nevertheless is able to function as a system that is resilient, self-sustaining, and livable. So thus, all of this, so processes, right, to generate data, they rely on data. So the question is, can we actually use data to improve the livability, sustainability, and resilience of these systems? That's basically the sort of overarching question of my research. So what we have done a couple of years back, as Professor Saharoğlu mentioned, I'm director of a center, Cascade. And the center basically is doing basically both federally funded as well as industrially funded research. So we sort of reached out to several companies that basically cover sort of a broad spectrum of applications, from healthcare to finance to energy to IT technology, right? And we asked them, what frustrates you? So what would you like to do today that you are not able to do? So what are your roadblocks? So this was basically, I believe, 4 or 5 years back. And the answers that we got at that time were that basically there are some key services that are essentially missing. Right? So those services, these are not my outcomes. So these outcomes basically come from this meeting. The service that basically the representatives of these companies indicated were integrated, federated, scalable data storage, analysis, and modeling. So basically, essentially data integration, right? So that was basically highlighted as one of the major sort of services that is today still lacking. The second service that was highlighted by this group of companies were making unstructured data queryable. And this is, again, very understandable because many of these companies, right, so collect data, right, so observations from the real world. And many of this data that's collected from the real world are unstructured. So they are not basically typed in by some data entry person, right? So into a structured database, but they are collected from the real world. So they are not structured. So those unstructured data has to be interpreted. That unstructured data has to be processed and has to basically be ingested into a system in which the decision can support decisions. So this was basically the second service that basically was requested by these companies. Now the third, fourth, and fifth I highlighted separately, right? And what I would call these are essentially, these are the services that are especially critical, right, in what I would call sense making, right? So they basically required analytics, network analytics, right? So as I mentioned, right, so we are basically in complex systems. We have network of processes, we have network of users, we have network of agents, right? And one of the services that basically this group of companies highlighted for us is essentially they need network analysis, right? So they need to understand the structure of this complex system, okay? And that requires basically you to understand the entities in the system, right? And understand relationships between these entities in this system, right? So they basically told us we need network analysis. We need to understand basically the system that we are operating in, right? The fourth service that they required or they asked us was discovery, right? So they said that we would like to discover patterns. We would like to discover emergent patterns, especially when those patterns are emerging. Okay, it turns out emergence is a critical aspect because real world is changing, real world is dynamic, and in a dynamic setting, right? So you have emerging patterns, right? So the patterns basically don't stay the same, they change, which means that you need to basically discover those patterns. And importantly, you also need to discover the causal relationship between them. What causes what? Okay, is A causes B? Does A cause B? Right? Is A cause of B? Right? So they told us that basically understanding patterns and then understanding the causal roots of those patterns are critical for them, right? So to support their smart services, right? So smart applications, smart processes, right? So that was another service that basically was requested from us, right? The fifth service that was highlighted, okay, was validation, right? So again, as I mentioned, right, the real world evolves, right? So you look at the real world, right? You create models of the real world to use to support your decision making, okay, right? But those models, right, first of all, may rely on incorrect data, may rely on stale data, right? So those models have to be validated, right? So you need to always look at the models, okay? And you have to ask, is model valid? This model was valid yesterday. Is this model still valid, right? So basically model validation, right? So is actually a critical challenge in a dynamic system, right? And beyond validating the model, right? So can you look forward, right? So can you use these models okay, to support forecasting, right? Again, this is difficult because your model, okay, might be valid today, okay, right? So it doesn't necessarily mean that that model is going to be valid tomorrow, but forecasting means looking future, right? So then the question is, right, okay, are the models predictive? Okay, they may be descriptive, they may describe today very well, they may describe yesterday very well, okay, right? But can we develop, okay, predictive models? Can we develop models that's going to help us make decisions for not today, okay, but tomorrow, but the day after that, the month after that, right? So these were basically highlighted as the 5 services, okay, that will be critically needed, okay, by this. Again, this was not an extensive group. There were basically 20, 30 companies there. They are not necessarily, I'm not going to claim that that's basically everybody, right? But these basically were highlighted as the core challenges and common challenges that basically these companies faced, right? So what I would claim today, right, so as a starting point, right, is that these 5, okay, would be the smart data services, okay, that we should be striving for, we should be sort of working towards. Okay, and this basically became actual motivation for our research, these 5 services that are lacking. And many of the grants that basically I mentioned were motivated by these challenges, right? So, and I will basically try to tackle some of these and mention some of these today. Right, so again, just to underline, okay, right, so the claim is that situational understanding, right, so is important, right, in complex systems, right, and developing situation and understanding is especially important, right, to support effectiveness, efficiency, and safety, right, in human-centered systems. And safety becomes especially important, okay, when we think of the humans, right, because if a process doesn't involve a human, okay, safety becomes less critical, right? But if you are talking about a system, right, so that involves humans, that are human-centric, right, safety also becomes very critical. So a very good example of this, again, going basic with the smart sort of X idea, is smart cities. Smart cities and IoT, right? Obviously, a smart city, right, so is a beast, right? So it's an entire city, okay, with its various sort of services, underlying services like transportation, logistics, underlying information network, underlying energy network, underlying water network, right? So it is basically it's a system of systems, right? And this system of systems, right, so generates like a large amount of data, especially today, where basically many of these processes are sensed. There are sensors associated with many of the equipment that is deployed in a smart city, and that's basically what we call Internet of Things, IoT, right? But basically, the system essentially requires, right? Not data generation is good, right? But you need to be able to gather and integrate this data, right? You need to be able to provide the health of a smart city. You need to basically provide real-time and continuous analysis, right, of the data that you are generating, right? And you need to basically feed this integrated and analyzed data into a model, into simulations and models, right, that can support decision making and that can support forecasting, right? And this is this modeling and simulation will be critical. Okay, I'm actually going to spend some time, if time allows, I'm actually going to spend some time on modeling and simulation, because it turns out that modeling and simulation becomes a very critical component, right, of forecasting in complex systems. And it turns out that it's also not very easy. Okay, it becomes actually quite challenging to create a simulation platform that can support simulation of a very complex process. And I will basically try to motivate and explain some of those challenges shortly. Right? So the brief, again, statement is that a smart city is a smart city, right? So only when it's complemented with a real-time integration and pattern discovery, right? And human-centered technologies, right? So that can continuously ingest and digest real-time data streams, right? So that's basically essentially what a smart city is. Okay. So one specific challenge, right? So in many of the smart, many of these human-centered dynamic systems that is interest to me is the fact that many of these are multi-scale. So what do I mean by multi-scale, right? So for example, if we take a building or a building cluster, right? So and we work with basically companies that provide energy support, building energy management for buildings and building clusters, right? So in such an environment, right? So usually temporal scale is small, right? So you are basically making decisions minutes to days, okay? Whether you turn on the AC or whether you turn off the AC, right? So when do you start the heating so that the comfort level is at a reasonable level at a given point in time in the day, right? So decision is basically made in minute to day, right? And the spatial scale is also small, right? So we are talking about rooms, levels, a building, at most a basically building block in a city, right? An administrative scale in this case is also small, right? So usually there is a single decision maker, right? So if we are, for example, talking about a university, right? University is a building clusters, and usually there's a single decision maker, right? So that decides when basically the building is going to be heated, when it's going to be cooled, right? So we can think of this essentially as a sort of a small scale, single administration, right? Environment, right? But these are not the only human-centered systems, right? So emergency response, okay, turns out to be another important smart city service, right? And in the case of emergency response, for example, responding to disasters, okay, right? So the time scale changes, right? So now we are operating, okay, in days to weeks, okay? Basically, if we are talking about an earthquake, we are talking about hours to days, okay? If we are talking about a hurricane, we are talking about days to weeks, okay, right? So sometimes you have days basically to prepare, right? So to a hurricane, because the hurricane is coming, you know that it's coming, you have some time to prepare for it, right? So the temporal scale grew, right? The spatial scale, okay, also grew with that, right? So now basically a hurricane or an earthquake, okay, can hit a city, right? Or maybe sometimes multiple cities, right? So essentially spatial scale is also much larger, okay? And administrative scale, right, so also grew. Okay, now you don't have a single decision maker. Okay, right. So you have, in this case, often largely cooperating, okay, but loosely coupled administrative structures, right? So you have the emergency response units, you have the police, you may have basically military that's basically providing some help. You might have basically, if you have multiple cities, you have basically governors of multiple cities involved in it, right? But usually basically cooperative, right? That involves basically multiple decision makers, right? On the other extreme, right? So we have response to a pandemic, right? We are basically sort of living through this as we are speaking right now, right? So these are large human-centered dynamic systems, right? So we are talking about weeks to months. Okay, it turns out that this pandemic is already beyond a year, right? So we are talking about years, right? And the spatial scale is also very large, right? So we are talking about nation, even world, right? So in COVID-19 is a great example. We are basically, what's happening basically in India today, right? So has an impact on what will happen in the US tomorrow. So there is actually a world scale impact, right? And the administrative scale is also world scale, right? And most critically, okay, right, it's composed of, right, so not only cooperators, but also competitors, right? So for example, when there are multiple nations, right, so that are sort of competing, right, so against basically a limited amount of sort of PPEs or limited amount of testing units or limited amount of vaccines, right? Suddenly you have competition, right? And again, basically beyond competition, you also have cooperation, but under different assumptions, right? So you can have or under different policies, right? So you have different nations, right? So that may have a completely different and sometimes conflicting, right? So policies, right? So public health policies, right? So these are basically things that needs to be considered, right? So to understand the nature of the epidemic, nature of the pandemic, right? And also basically to make decisions, right? You still have to, even though there are multiple other agents, you still have to make your own decision, right? So as a city, as a city governor or or a state governor, of a nation governor, right? So you still have to basically make local decisions, right? So how do you make those local decisions, right? So among these competitors and among these collaborators, right? In this global scale event, right? So essentially, so one of the major challenges, right, of basically complex systems, right, so of human-centered complex systems, is that they are multi-scale, right? So we need to basically, different processes operate at different temporal, spatial, and administrative scales, right? And most critically, right, in many cases, right, these processes, okay, coexist, right? So for example, especially when we think of a pandemic, right? So pandemic, right, so it has to be considered at a business scale, right? So a university, right, so it has to have its own policies, right, to have how they respond, right? A city, right, so has basically its own sort of structure, right? So both in terms of epidemic as well as testing, as well as vaccination, right, and hospitals, right? You have basically at the nation level, right? So some of the processes operate at the nation level, right? And some of the processes operate at a global level, right? And decision making in such a setting, right, so requires you, right, so to consider, right, so things at multiple scales simultaneously, right? So you cannot just say, okay, I'm going to look at everything basically in a month level, right? That doesn't make sense, right? So because certain things are happening at the day level, certain things are happening at the week level or 2 weeks level, right? So if you make a closure, right, so that's basically 2 weeks to 3 weeks, for example, right? So many things basically are happening, right, at different scales, right? So that basically makes, right, so decision making, right, so situational awareness and forecasting, right, so especially challenging. So, so the brief sort of outcome of this is that, right, because of the size and complexity of the data, right, and the varying, right, so spatial, temporal, and administrative scales, right, many times experts that are supposed to make decisions, right, do not have the ability, right, so to understand and predict these relevant processes, right? So it is not like basically you have a little chart that can show you everything, right? So the process is so complex, right, that you need to look at it from different angles. You need to analyze it in different ways, right? It possibly at different scales to support decision making, right? But the experts or many individuals that are at the decision making level, right, or responsibility, right, are not data experts, right? So we are data scientists, we are data engineers, many of us, right? So I don't know everybody in this audience, but I assume some of you are, right? We are equipped to handle that to some degree, right? But many of the people who are supposed to make those decisions are not, right? So then essentially the question really becomes, right, can we actually support, okay, those individuals, right? So can we support decision-making in a dynamic world, right? So what does this involve, right? So what does decision-making in a dynamic world involve, right? Of course, it involves many things, right? So I'm basically, it involves obviously organizational structures, involves social structures, it involves policy structures. I'm not going to talk about that, right? I'm talking about basically the data side of it, right? So from a data perspective, right, so it involves basically 4 things really. Okay, we can sort of summarize them into these 4 boxes, right? The first box is sense and integrate, right? So we need to be able to take inputs, okay, from diverse sources. Okay, that's the sense component, right? We need to be able to unify, integrate, okay, right, this data, right, to support understanding. Okay, so sense and integrate. So that's sort of the first box. Okay, so that's basically the box that is basically closest to the edge, closest to the events that are actually occurring. Right? So the second box is analyze, simulate, and predict. Okay, so this is where basically we take the integrated data, right, and we support situational awareness, right? We basically create models, okay, that basically explain the data that we have observed, right? And these models, right, so some of them may be physically based because we know underlying physical physics, right? So for example, if a hurricane is developing, right, so we know basically the underlying physics of the hurricane, right? If it is an epidemic, right, so we may or we may not know, right, so some aspects, right, of that epidemic, right, but we know that it's an epidemic, so it behaves generally a particular way, right? So there's physical aspects, right? But there's also data aspects, right? So some of the models that basically people have been successfully using are purely data driven, right? So they are basically learned from data, right? So the question is, can we basically actually use, right? So this integrated data to create physically or database models, right? And basically, can they basically be used for simulating the future so that basically we can do predictions, right? So that's basically sort of the second box. The third box, again, basically is going to what basically these companies ask from us, validation, right? So validating to interpret, right? So don't basically, if you have a model, if basically you run this, your analysis, if you run your simulation and the simulation told you this is the best model available, right? So that may not be the case, right? So that may be the case today, it may not be the case tomorrow, even if it is, even if it were today, right? So you need to basically be able to validate and interpret those models, right? So you need to validate, right? So to make sure that basically it's always that model is fresh and that model is applicable, right? And you need to interpret, right? So within the context of domain experts, right? So this is where actually domain experts are, humans are again basically critical, right? So the models as well as results of those models, right? So have to be interpreted, right? So explained and interpreted, right? So by humans, right? To see, to basically ensure that the models, right? So are trustworthy, right? And they can be supported for accurate decision making, right? So many times actually a bad model, a poor model is worse than not having a model, right? So because it can guide you in the wrong direction. It can actually instead of helping, it can actually hurt, right? For example, at the beginning of the COVID pandemic, right? So we were told that we shouldn't be using masks, right? So it turned out that that was a poor, that was not necessarily correct, right? So the interpretation changed, right? So it is important that basically if we have a model, right? So we need to basically be cognizant, right, so about the fact that that model, okay, may not be valid and that model may need to be revised and updated, right? And the final sort of box here, right, so is act and adapt, right? So essentially we need to be able to act, right? So we need to be able to basically take these models and take the results and give it to decision makers, right? And again, decision makers and who are going to act in the real world, right, are also humans, right? And humans are limited, right? So we cannot basically remember too many things, right? So we cannot basically, if we operate very well in three dimensions, right? So when things are three-dimensional, we are able to handle that, right? So but if it is not three-dimensional, if it is a higher dimensional process, we are not good at interpreting that, okay? Because our brains are three-dimensional mostly, right? And we don't understand statistics very well, right? So there are actually pretty good studies that show that humans are not good at large numbers, interpreting large numbers or understanding probabilities, right? And our decision makers are also humans, right? So which means that basically we need to be able to provide this data, right? So to decision makers in a way that basically they can act in the real world, right? So if your model must be maybe great, but that model has to, the results of the model has to be presented to the actors, right? So in the most appropriate way, right? And very importantly, right? So you need to adapt, right? So as I mentioned, so the real world constantly changing, right? Okay. So which means that you need to basically continuously adapt, okay, the models that you created, right? So you act in the real world, okay? The real world changes. Your actions may change the real world, right? Which means that you need to keep sensing the real world, right? And you need to basically continuously adapt the models, okay? And that continuous adaptation essentially starts the second cycle, right? So you need to basically keep observing, keep sensing, keep integrating, keep analyzing, keep validating, and keep acting, right? So this is essentially basically what I would call the decision-making cycle, or this life cycle, right? So in a dynamic world, right? And then one thing that you will notice essentially is the data is at multiple places here, right? So it is basically in all the phases of this, you need to basically be dealing with data, okay? Sometimes the data is collected, okay? So you need to basically look at the data collection and integration. Sometimes that data has to be analyzed, okay, right? So you need to create models. You need to create basically predictions, okay? It turns out that those models and predictions are also data, okay? I will try to explain that time allowing, right? And those models and predictions, right, has to be then be given to decision makers, right? So it's sort of process data, right? So they are not raw data, now they are process data, right? But they now have to be presented, right? So these decision makers, either for interpretation or validation or for action, right? So that those are basically all of them, right? So are challenges, right? So in data-driven decision making in the dynamic world. So going back to the core question, right? Can we make sense, right? So of data, right? So to support decision making, okay, to support our smart service that we would like to provide, right? So, I mean, I've been using this term sense making, right? So decision making, we all know, right? So what does sense making, right? So why am I using this word, right? So what does sense mean, right? And obviously, my name is Tels, right? So Kasım CANDAN. So I'm Turkish, so English is not my first language, right? So when I don't know something precisely, right? So I go to the source, right? That's what we do. We are scientists, we are researchers, we go to the source, right? So one thing that basically I've done a while back is open the dictionary, right? So what does sense mean, right? So it turns out that sense actually have two meanings, right? So, and that's basically very interesting, right? So the first meaning of sense, or first sense of sense, right? So it's actually three meanings, but it's something else, comes from Latin, sentire, okay? And it means to perceive. Okay, it's really about perception, right? This is the meaning this is the meaning of the term sense in sensing, right? So you sense, you perceive. Okay, these are the real world stimuli. Okay, that you collect. Okay, that's the first meaning of sense, right? The second meaning of sense, okay, is very different. It's very different from this, right? It is about having awareness of and understanding of things, right? So basically being able to map things to concepts, to categories, okay? Not that these are very different meanings, okay? The same word, okay? Very different meanings, right? In fact, there's a huge gap between these, okay? So the first gap, right, is basically about raw data, collection of raw data from the real world, right? The second meaning is understanding and interpreting, right, at a very high level concepts, okay, right? So there's a huge gap between these two meanings of the same word, right? Okay, but very interestingly, right, so that gap is actually, okay, what I mean as smart data services, right? So whatever you need to do, right, so to bridge that gap, okay, going from stimuli, right, so real world stimuli, raw data, right, to high level concepts, right, is essentially, right, so require, right, some tools, some technology, some algorithms, right, some platforms, and those are essentially what we call smart data services, right? And essentially my research tackles, right, so I'm an individual, I have a research team, I have a center, but nevertheless, right, we cannot do everything, right? We are basically sort of trying to tackle, right, so some of the key challenges underlying this gap, right? So bridging this gap. That's essentially basically what the research is about, right? So I mentioned some of the challenges, right? So what are those challenges, right? So why is this bridging this gap, right? So it's a major challenge. Why is it a challenge, right? So what do we need to do? Do we just need to develop databases? Do I just need to put everything into an Excel file? What are the challenges? Why is this a big deal, right? So why are all these companies find these challenging, right? So it turns out that, right? So smart data, right? So have various aspects, right? And that leads to what I would classify as sort of four group of challenges. Okay, right? So the first group of challenges are known as 3 V's. Okay, and any of you, right, so who are in the sort of data community, right? So you have heard of these 3 V's, right? So these are sort of the 3 V's of big data, right? Volume. Okay, sometimes data is a lot. Okay, right? So a lot of data requires a lot of processing power, right? So volume is an issue, right? Velocity is an issue. Okay, sometimes data come very fast. Okay, you are collecting data from the real world. It's coming basically at an immense speed. Okay, right? In a smart city like setting, it's coming with an immense speed. So you have to act very quickly on that, on the immense data speed, right? And variety, right? So you're observing different things. You're observing basically text, you're observing numbers, you're observing images, right? So you have a variety, right? So this variety also creates challenges, right? So because as I mentioned, right, so these need to be integrated, and integrating a variety of data is a challenge, right? So these are commonly known. There's the 3 big V's of smart data or big data, right? So we need to basically be able to address these, we need to be able to solve these, okay, to be able to support the decision-making process, right? But it turns out that these are actually not the most difficult ones, right? So these turn out to be actually pretty easy. I'm not going to say easy, right? So because there are still challenges, we still don't know how to address some of them, but they are still more easily achievable than many other challenges that the data throw to us, right? So what I call the HMLE challenges, right? So it's sort of the side bar, another sort of dimension of this, right? Is that data, right, is often very high dimensional. Okay, very high dimensional doesn't mean that we have a lot of data. Okay, it means that we are observing, okay, many different aspects of the data simultaneously. Okay, right? So for example, right? So if we are observing a smart city, we are observing many different aspects of the city simultaneously. Okay, or say you are a advertisement company and you want to basically sell a product, right, so to an individual, right? You are observing many different aspects of that individual, right? So you're observing buying history, you're observing reading history, you're observing watching history, you're observing friendship history, right? You are observing many things about the same individual, right? So you have a high dimensional data. Okay, it turns out that the higher the number of dimensions you have, okay, right, the exponentially more difficult, okay, right? So making decision-making out of that, in that context, or creating a model becomes, okay? So that's basically a major challenge, right? So real-world data is high-dimensional, right? Real-world data is also multimodal. Now, multimodal is similar to variety, but it's not exactly the same thing, okay, right? When I mean by multimodal, okay, what I mean is that the data, okay, is sometimes temporal, sometimes spatial, sometimes it's a set, sometimes it is a graph, okay, it's a network, right? So these turns out to be fundamentally different from each other. They require different ways of storing. They require different ways of analyzing. They require different ways of visualizing. They are different, okay? And in many cases, however, although they are different, they coexist, right? And in some cases, actually, from the same data observation, you can generate multimodal features, okay? Which basically means that they coexist, right? And that makes basically, again, the problem significantly different. Data is interlinked, right? So remember, I mentioned that we make observations, right? But there are linkages between these. Again, if it's a smart city, if I'm observing a city, right? The observation that I make at different aspects, different processes, different layers, different locations, different time, okay? They are linked together. They are not completely independent from each other, right? Some of these linkages are known ahead of the time. I know that this individual and this individual are friends. I know that there is a plane that is going to fly from this city to this other city, right? I know that this building and this building, there is a door between them. So there's the airflow between them, right? So some of these linkages I know, okay, right? So it's known ahead of the time, okay? But many linkages are not known ahead of the time, right? So those linkages, especially causal linkages, okay, may not be known ahead of the time, right? And they need to be discovered, okay? They need to be discovered and they need to be used after that, right? So to support modeling and to support decision-making, right? So the world is interlinked and those linkages are critical, right? So for us to create useful models, okay, right? And evolving, right? So evolving basically is kind of similar to velocity, but it's not about velocity, right? Things can be fast, but may not change, okay, right? So I can basically have a building, right? So being observed during the day, okay, right? Lots of basically people will be moving in, moving out, okay, yes, there is changes happening, okay, but it's not really evolving, okay, right? So because it's not changing. The model basically that I have, say at 1 p.m. for energy usage might still be applicable at 3 p.m., okay, because the system didn't evolve much, right? But then when the night comes, okay, right, suddenly basically the model has to change completely, okay, because the system fundamentally changed, okay, the system evolved, okay. The model that I had at noon time is not applicable maybe at midnight. The model that I have for a building in the summer may not be applicable in the winter, okay, right? So things evolve, things change, fundamentally change, right? So we need to basically be able to detect those changes, okay? And we need to be able to modify the way we collect data, the way we process data, the way we analyze data, the way we act on the data with the evolving world, right? So that's basically challenging. On the other corner, right, so we have what I call SINT challenges, right, S-I-N-T, okay? S means sparse, okay, right? Yes, we may have a lot of data, right? So we have sometimes a lot of data. We are inundated with data, right? But those data, okay, right, may still be not sufficient, may still be insufficient, okay, right? Yes, hurricane is coming, right? So you are observing a lot of data, okay? It's coming from different agencies, different places, right? But still you may not have sufficient data, right? So to decide, okay, where to place your emergency services, okay, right? Yes, you want to sell an advertisement to Selçuk, right? You have a lot of data about him, right? But that data may still not be sufficient, may still be insufficient, okay, to characterize preferences of Selçuk, right? So to pick one or the other product to show, right? So data, okay, especially if when the models are high dimensional, right? Even if you have a lot of data, right? So that may not be sufficient, that may be sparse, okay, right? The real world observations are imprecise, okay, right? So many times you don't basically get perfect observations and it may be noisy, okay, right? There may be different reasons, especially real world sensors are many times noisy, right? So you have different type of imprecision and noise, right? And also trust, right? So do you trust all of the data sources, right? Especially in the world that basically we are living with fake news, trust basically becomes a critical issue, right? So which data sources do you trust, right? So, and this basically is especially important, right? So when basically you are dealing with in a sort of a global scale, things like a pandemic, right? Where you have competing agents, competing interests, right? So do you trust all of the information sources, right? Do you and this may not be basically misleading simply because some of the places, right, so may not have good data collection, okay, right? So because their data collection system is not perfect, right? So you are getting data from that location, right? Is this information trustable? Right? So those basically become, right, so critical challenges, okay, for you to make a decision, right? So you need to basically collect data from your cooperators, from your competitors, right? And you need to decide, right, so which of these is trustable, right? So that basically becomes very important, right? So those are some of the key data challenges, right? So in the dynamic world, right? And as I mentioned, right, so we have humans in the mix, right? So it's not all about the data, right? So in many cases, both the data sources, right, and the data consumers, right, so are humans, right? Which essentially basically means that, right, so we need to deal with humans. Okay, as I mentioned, humans are limited, right? So we have limited capabilities, right? So we have limited memories, we have limited ability to understand high dimensional data, we have limited ability to understand large numbers, we have limited ability to understand statistics, okay, right, or probability, right? Which means that basically we need to explain data. So explaining becomes important. Accessibility becomes important, right? So because some of the users and some of the consumers, some of the people that are living in this environment, right, so are disabled, right? So accessibility becomes important, right? And privacy also becomes an important, right? Especially when we talk about data collection, data integration, right? Privacy becomes critical, right? So how do I provide all the services that I want to provide, right? So by collecting all this data, okay, right? Yet okay, I basically provide privacy to Kasım, CANDAN. How do I do that, right? Can I actually do that, right? It's not entirely clear, right? So it is not entirely clear. So that basically becomes another challenge, right? So, so these are essentially, right? So the challenges, okay, that we have, right? So when we are basically dealing with different aspects of the data. So, I think I have 10 minutes. So I have, I hope I motivated, I use most of my time for motivating, okay, rather than actually providing solutions, right? In the remaining set of slides, I actually sort of categorize my remaining set of slides, okay, into two sort of sets, okay? The first set is about simulations, okay? And the second set is about time series analysis, right? I don't believe that I have sufficient time to go over them, and I kind of knew that I was not going to do that anyhow, right? So what I will basically try to do is I will try to give you guys some gist, okay, of some of the approaches, okay, techniques that we develop, right, to tackle some of these challenges, okay? Obviously, as I mentioned, the challenges are many, okay, plentiful, which is good for me because there's a lot of potential for research, right? It is bad, okay, for decision makers because they need those to be solved urgently, right? But basically, essentially, these are the things that basically motivate me and my research, right? So the first sort of project is actually not a single project. It is basically a culmination of basically several projects, right? So that basically sort of feed into sort of this idea, which we call data storm, okay, which is basically a platform for simulation as a service, right? And this is basically funded through several different aspects of this is funded through several basically grants. We have an NSF grant specifically funding the platform development data storm. There's an NSF grant focusing on application of this in epidemic modeling. There's another grant that basically focuses application of this on disaster planning and response. And there's also a European funded grant focusing on conflict, competition, cooperation, and complexity, and use of basically evolutionary games, okay, for understanding and simulating and modeling complex systems. So sort of different aspects of basically the project. And this basically project essentially primarily focuses on the lower half of things, right? So simulating, predicting, and validating and interpreting essentially, right? So again, why disasters? Well, disasters are expensive. It's expensive economically. It's also expensive in human cost, right? So according to 2010 World Disaster Report, right? So in the previous decade, the 1 trillion loss purely based on basically disasters and 1 million casualties, right? And this is basically putting aside more recent numbers, more recent pandemic and so on, right? Obviously epidemics, right? So is a form of disaster, right? And now we are basically seeing, okay, that basically being amazingly impactful because it's affecting any of these aspects that we care about in a smart environment, right? So our communities are affected, economy is affected, environment is affected, governance affected, living is affected, mobility is affected, right? So all of these are basically being affected, right? So obviously, right, so disasters, right, so required preparedness, first of all, right? So hopefully you are prepared for a disaster, right, before it strikes, and response, right? So these are sort of two sides of the coin, right? So you need, for preparedness, right, so you need to be able to basically forecast the disaster process, okay, right? For response, you need to be able to forecast the impact of basically your response, right? You need to basically be able to predict how basically people are going to move in the environment, right? You need to assess, right? So the impact of things like evacuation or things like basically controls, right? So if you basically close the if you have a lockdown, what's going to be its impact, right? So can you predict that, right? If you are going to only close the schools, what's going to be impact, right? So if you are going to close the transportation between cities, what's going to be its impact, right? So you need to be able to basically predict the impact, right? So what we call impact analysis, right? So of these, right? And you also need to be able to estimate, right? So secondary disasters, right? So many times disasters don't come alone, right? So for example, a epidemic, okay, comes basically with economic disaster, right? So an epidemic basically comes with a social disaster, right? So elderly becomes isolated, right? A hurricane, okay, right? So might come with the epidemic as a side effect because people are coming together and there's lots of water that is basically that gathers, which basically is many times leads to zoonotic diseases because you have lots of mosquitoes in the environment after hurricane, right? So you need to basically consider these different basically processes that coexist, right? And unfortunately, there's also not much room for error, right? So because every decision, okay, right, so have an impact, right? So in many times, not having a decision also have an impact, right? So you need both action and inaction, right? So have impact, right? So you don't have room for error, and you are basically both action and inaction has basically significant cost, right? From a decision-making perspective, as I mentioned, basically disasters actually pose all of the challenges that I mentioned earlier, right? So because they involve hundreds of interdependent parameters, right? So that you need to basically observe, right? They span multiple layers and geospatial frames, right? And they are affected of complex dynamic processes, right? So these are the original disaster, these are the response decision makers, right? So the response, how people behave during the disaster, right? And these dynamic processes are at different resolutions, right? So something's happening basically in the neighborhood level, something happening in the city level, something happening at the national level, right? So basically you have to deal with essentially all of these challenges that I mentioned earlier, right? And these evolve over time, right? So because before disaster hits, immediately during disaster and after disaster, right? So things change, okay? People's behavior change, okay? Right? So you need to basically be continuously able to adapt and remodel, right? So disaster simulations, right? So it turns out to be very expensive, okay, right? So because running and interpreting these simulations is very costly, okay, right? So because as I mentioned, basically you have to be able to, given all the unknowns that you have, right? So you need to often run many thousands of simulations, okay? And running and interpreting these simulations is also very, very, very expensive, right? And as I mentioned, right, so many times, right, so you don't have a single thing, right? So you have multiple processes that feed into each other, right? So you have a hurricane evolves, but hurricane also basically feed into a disaster, into a disease. Okay, so you need to basically be able to couple multiple processes, okay? And you need to be able to basically run continuous simulations of these multiple processes, right? With many times limited amount of computational resources. Okay, the available computational resources to you may not be infinite, right? So you don't have infinite time, you don't have infinite computing simulation, computing power. So you cannot basically run everything, right? So all possible outcomes. You cannot do that, right? So you need to be able to carefully select. Which simulations you are going to run. You need to be able to efficiently execute this in parallel, right? So in high performance computing systems, right? Now, it turns out that basically these simulations, right, that you generate, okay, also generate a lot of data, right? So you need to be able to analyze, okay, right? So the simulations that you have, thousands of simulations that you generate, you need to be able to analyze the outcomes of them, right? Okay, and you need to be able to basically revise, okay, right? So the simulations, right? So based on real world, right? So, okay, this is the simulation output, this is the real world observations, do they match? If they match, good. If they don't match, why don't they match? How do I revise my model? Which additional simulations do I have to run? Okay, right, so that I can predict tomorrow better, right? So those basically become, okay, some of the major challenges in basically simulation design. And essentially data storm, and I will take one more minute and then I will be done, right? So data storm essentially is basically a platform that we have been developing through several funding sources, right? That basically look at the underlying challenges, right? So how do we run simulations? Which simulations do we run? How do we execute these simulations? And these simulations generate a large number of time series data, right? How do we analyze these time series data so that we can basically support effective decision making, right? So I'm not going to go over basically I'm not going to go over the technical details underlying this, right? But there's one thing that I mentioned, right? So is that the simulations, right? So generate large amount of multivariate time series data, right? And it turns out that the time series data, right? So simulations generate time series data. If you are basically dealing with healthcare, right? So healthcare, for example, we have a project with the Phoenix Children's Hospital, right? So we are looking at the childhood trauma, seizures due to trauma in the brain of children. That generates basically time series data because we are collecting EEG signals, right? As I mentioned earlier, basically we are collaborating with basically companies that will develop energy solutions for buildings. Building basically also generates a large amount of time series data, right? These are multivariate time series data, right? So in all of these, essentially what you have to do is you need to basically sort of analyze, okay, this multivariate time series data to discover key events, to classify these key events, to learn causal models, right? So because you have multiple variates, right? So you try to learn causal relationships, right? So between the observations that you are making, right? And you need to be use them to predict your future events, right? Essentially, so I'm not going to go over basically the technical aspects of this. So we have some very good results, okay? But I will basically end with the, I ended a bit too early, just one, Professor, just 1 minute, okay, right? So I will basically end with this, right? So this is the conclusion, right? Today, right, so the amount of data is generated massive, right? This then necessitates, right, so engineering, right? So this is this is especially important. This is a Mühendislik faculty's presentation. It's especially important to highlight it. This requires engineering of new architectures, right, that can match the scale, okay, right, so to support decision making, analysis, forecasting, right, so to generate value, right? And essentially my research, right, so is engineering of these systems, right? And I'll be, again, this was 1 hour, right? So I couldn't present much. I hope I motivated, right? So some of these challenges, and I'll be very happy to discuss, right? So with you guys, right? So offline, how these can be done, and maybe some collaborations will come out of that. Thank you so much. Thanks a lot for your patience and your interest. Professor Saroglu, I'm done.
Okay, thank you very much, Professor CANDAN. It was really interesting and a very important topic today, understanding the data world, and especially starting from decision making, sense making. But it seems that we have to be more concerned than before, especially sensing, data sensing models really give new direction for research side and also applications side. But when we consider human-centered technologies, actually, we are getting a bit frustrated, as you also mentioned that, privacy concern is important, security concern is important, and also safety side, as you mentioned. And also, we are getting future concern. You see, concern degrees increasing step by step. So we have to find better models and to represent and to protect data, to get, as you said, generate value from those data, and also give better services, as you explained. Thank you very much indeed. We have a few questions, I think. Let me ask our audience.
I know I used the full hour. I apologize for that. So
I can ask you the question if you want. Can you see the chat?
The chat. Sorry, I didn't see the chat. Let me open my chat window. I don't see the. Unfortunately, I don't see the questions. Unfortunately, I don't see the questions.
I will ask you a question. Rıdvan Güler ask you question. Do they employ any blockchain technologies on the system? If no, do you think it would be possible to improve such combined system in the future?
Oh yeah, definitely. We actually recently bootstrapped a blockchain research lab as part under the center that I'm heading, and right now that center is basically received funding from the state of Arizona. as well as basically several companies who are both developing and deploying blockchain technologies. A blockchain basically provides significant opportunities, right? So it is a distributed ledger, right? So especially when you talk about basic decentralized systems with basically multiple agents that need to share data in a way where you don't have a central trust mechanism, right? That basically becomes a critical tool, right? It is not perfect, right? So it has basically limitations. You need to be aware of those limitations, right? So it is not always basically the right solution. Sometimes basically actually central data, if you have a trusted agent, right, that you have, right? So sometimes you actually, some technologies might be overkill, right? Sometimes you don't need a distributed ledger, right? So it is important for us to understand, right? So when you need a distributed decentralized ledger versus a centralized ledger. And we are looking into that. We actually have a project right now looking at use of blockchain technologies in food security, food safety. That's basically one of my students is working on that. But as I mentioned, beyond that, we recently bootstrapped a blockchain research lab, and we are investigating that in different aspects, right? So both basically from the use aspect, as well as sort of limitation of the blockchain technology like scalability, right? So transaction bandwidth, public versus private blockchain. So we are basically looking at that as we speak. Excellent question, definitely. It is one aspect of basically making data available, right? So in a decentralized context. Beautiful question. Thank you for asking.
Okay, thank you, Professor CANDAN. Let me ask a question. I checked the audience. You know, there are graduate and postgraduate students is our participants. And what is your suggestions to understand these human-centered technologies and especially theory and practices? You know, what is your suggestion to those students? What they can do for their future development, future career as well? What is your suggestion to them, especially in this topic?
Yeah, I mean, that's a very good question, Professor Sarov. I mean, one thing, right? So again, I don't know everybody's interest, right? So if you are interested in data, let me basically start from there, right? So if you are interested in data, right? So, but you are aware that basically the data exists in a complex environment, right? So we don't, it was basically 20 years, 30 years back where basically data was contained within a database and then that was it, right? So we need to be aware that basically we need to be aware that basically, and also as computer scientists, right? So we need to be aware that basically we don't own data, right? So I'm a head of a director of a center on data, right? But we don't own data, right? So we don't generate data. We also generate data when we create simulations that generate data, right? But the data, right? So is elsewhere, right? So other people have data, right? So scientists have data, decision makers have data, right? Data is everywhere, right? So domain expertise is outside of us, right? So we are not domain experts. As I mentioned, I have grants on epidemics. I have grants on building energy. I have grants on childhood brain trauma, right? So these are not my expertise. Okay, I cannot claim that I'm an expert, right? So, and I will never be an expert on those topics the way basically my collaborators are, right? But an important aspect, right, so is that we need to be able to collaborate, right? So as a data person, right? So especially if you are basically going to be a data person, right? So you need to be aware that, right? So you will need to interface, right? So with other individuals, right? So who are right? So the domain experts, right? So which means that we need to be able to listen to them, which means that we need to be able to understand their needs, okay? Which means that we need to be able to understand their challenges, okay, right? So different applications have different challenges, right? So not all applications have the same challenge, right? As I mentioned, brain trauma creates multiple time series, right? Buildings create time series, right? So disasters create time series, pandemic create time series, let's assume, right? But all of them are different. Their nature are different, the needs are different, the characteristics are different, right? Which means that basically, in addition to, right, so knowing the technologies, right, so techniques and technologies in your own area, right, so you need to be an expert in your own area first of all, right, so you need to know what basically what your own area basically is able to do, right? But you need to be able to basically make linkages, listen, right, so an interface, right, so with people in other domains, right? So they have the data, they have the challenges, we develop services. I didn't select that term lightly, right? So we provide services, we provide smart data services, right? And to provide the services, so you need to basically understand, right? So who are your service consumers, right? What basically they provide you as data and challenge, right? And how can you provide the data service to them in the most effective way, right? So which means basically try to listen, right? So try to understand, right? So and try to basically make connections, right? So beyond essentially your expertise, try to be comfortable, right? So you will never be an expert in the other area, right? So other folks are thinking of that for months, for years, day in, day out, right? So you will not be able to do that, right? But still, you need to be able to basically feel comfortable, right? So to listen to them, explain them, right? Because they are not data experts. You are the data expert. You are the computer science expert, right? So you are the engineer in many cases, right? And we explain them the limitations, the opportunities, limitations, right? And help them, right, to tackle their challenges. So, Professor Sarov, I don't know whether this is the answer you were looking for, but to me, this is what I really try to give to my students as much as I can.
Yeah, thank you, Professor CANDAN. You know, they have to be ready for future development, broaden their horizon not in specific topic and in different topic as well as.
Exactly, right? So exactly.
There is also one more question, or two more, or many. Işıl Karabey is asking, do Professor CANDAN have any predict system about the future of COVID-19, or do you have any research about it? You said already.
So we have an ongoing collaboration, right? So with computational epidemiologists, right? So we are actually working on that with National Science funded research. So we are specifically looking at coupling, as I mentioned, right? So many processes are not independent, right? So we are actually looking at the coupling, testing, hospitalization, and disease modeling. So your testing policies, right? So have an impact, right? So on the disease evolution, right? Different testing policies, the frequency with which you test, right? So the type of test that you apply, given that different tests, right? So do not have the same accuracy, right? And the same cost, right? So they have different, given the same number of tests, depending on how you apply testing, right? Can have different impact, right, on the evolution of the disease, right? So and early in a epidemic at the early phase, right? So you need testing for two reasons. You need to test basically to decide to understand who is sick, but you also need to test to understand what the disease is, right? So we are catching, for example, variants of a disease because of testing, right? So we test people, right? And we basically get we notice that basically, okay, something's changed, right? So it doesn't look like basically the disease yesterday, right? So what is this new disease? What are the parameters of the new disease, right? So testing becomes actually an important component. It's a data generation component, right? Of the epidemic process, right? So we are looking at basically coupling, right? So testing policies, right, with the response policies, right? So and that's basically a grant that we are working on. So was that the question, Professor Saroglu, or
he was asking you, do you have any project or studies on COVID-19? You have
we do. If Işıl Karabey basically would like to learn more about it, right? So I will be happy to basically discuss. I'll be happy to basically
for maybe
discussions and so
for future collaboration.
Certainly, yes, definitely. That's something that's basically quite relevant, right? So, and that's definitely basically we are interested in exploring that further.
One of our audience finds your speech very interesting, and he's asking you, when we try to make a decision and making a prediction about tomorrow probabilities, is there any parameter which will be able to help the interpret the future from the old history data? What he's asking. The answer is
Yeah. So okay. So yeah, I mean, it is a challenge, right? So basically, first of all, prediction is different than basically description, right? So the models that you develop, right? So for prediction are different than the models that you develop for description, right? So first of all, those are different, right? Interpretability is especially important, right? So because I can basically give a number to you, right? So I tell the decision makers tomorrow, right? So this many people are going to pass away from this, right? So it is useful information, right? But many times, right? So you need to interpret that, right? So you need to basically say why this is happening, right? So how can that be prevented, right? So many times decision makers don't need just a prediction, right? So they need the entire context, right? So that led what we call provenance, right, of that prediction, right? So that the prediction can be interpreted, right? And sometimes basically you need to be able to explain things, right? So you need to be able to explain. You show a curve, right? That curve may be very precise, okay, right? So, but maybe too difficult to interpret, or maybe basically be less precise, but easier to interpret, right? So which one? Which one is more useful to a decision maker, right? So that basically becomes explainability. Limitations of decision makers become critical, right? So explainable machine learning, explainable predictions, right? So is a especially big challenge, right? So it's actually becoming interpretability, right? So and explainability, right? So become as important as accuracy, right? And there is quite a bit of work, right? So in improving explainability, right? And different machine learning approaches, right? So have different degrees of explainability, right? So for example, neural network-based approaches, right? So they are more or less black box. They are not physically based. They can give you predictions, but those predictions may be very, very difficult to explain, right? So or interpret or revise, okay, right? Whereas some other approaches, right? So might be more easier to interpret and more easier to trust, right? And those are some of the things that basically are very critical, and we are also looking at that. And I'm happy to, if I don't know in this 2 minutes I'm able to answer, but anybody in this audience, right? So if you want to basically take this discussion and basically continue, right? So I'm happy to basically set up now that the Zoom is there, right? So we can basically take a separate Zoom meeting and chat, and I can try to understand your questions better and hopefully try to answer them maybe more completely.
Dear Professor, thank you very much indeed. You know, they are really good questions to be answered for the future as well. We have to focus on
difficult questions. Very difficult
well,
questions.
We know that the basic of the science is data. We have to deal with data and then find new ways, new concept, new perception for the future development. And today, your topic really gives us a very different perception or new perception, and we have to use those perception for future development. Thank you very much indeed. I would like to thank you to you on behalf of engineering faculty and also Gazi University. Our rector also sends his regards and special thanks to you. And this is the certificate from our rector. And really, we appreciate too much for your effort, for your time, for your interesting speech. Thank you very much again.
I appreciate. Thank you for the opportunity. Thank you for the opportunity. I do appreciate. I definitely
I'm sure
appreciate.
we do some joint collaboration in future, dear Professor.
I hope so. I
you.
definitely hope so, and I'm hoping to hear also from the audience for future discussions and future collaborations.
Yeah.
Thanks, Professor Sarıoğlu, and thank again to Professor Yıldız for the certificate appreciation. Much appreciated.
Okay. Thank you. Bye bye.
Bye.
See
Thank
you,
you all.
see you next time. You know, it's we'll
I hope so.
continue.
Yes, face to face.
Okay.
Hopefully.
Take care. Bye bye.